The Ghost in the Machine. It was a Styx album, wasn't it? I think it was. No, it was a Police. The Police. It was the Police. Much better band. So, the average until a repeat, to write it out exactly as Chelsea correctly broke it out for us, you had to do 2 times 52 plus 3 times, how many times? 107.
4 times 100.
4 times 100?
5 times 88.
Thank you, guys.
21. 7 times 4.
And 7 times 4.
Divided by 372.
All by 372. I heard it came out to 3.8, yes?
3.81.
There you go. It's going to take 3.8 rolls, or about 4 rolls on average. So in other words, you roll the first number. Expect 2 to be different than that first one, and then expect 1 that's going to match one of those first 3. Does that make sense? So you're going to roll a number, expect 2 more that are different from each other and the one that came first, and then expect the 4th one to match one of the first 3. That's what that tells us. Isn't that slick? It's kind of slick. I think it's kind of slick. So the idea, that's how you would calculate this in lieu of a algebraic formula, which I'm going to show you the algebraic formula momentarily. But in lieu of that formula, this is how you would get the answers you need. You just watch it and watch what happens. Jeremiah, it's tied back to your flight simulator in that those parameters that you know about, those parameters you said you set, yeah. Those parameters are the results of decades, if not scores, if not hundreds of years of observations. Right. We have seen that nowhere in history has it gone higher than 7 or lower than 2, so therefore we're going to generate numbers between that 2 and that 7. And not only that, we're going to generate more numbers between 3 and 6 than the 2s and the 7s because those happen more frequently in reality. Is that fair enough? Yeah. Good, good. Trey, go ahead.
So what is the point in knowing until all sides are shown?
That's the next one, right?
Yeah.
It's called the coupon collector's problem. And what it is, I don't know how to give you a point outside of the description of the problem.
It just has to be there. Is that just...
Well, it's a way of knowing, it's a way of upfront knowing how many resources you're going to have to expend to get a certain result. Suppose the result is randomly seeding a field with fescue seeds. And you're going to do it via some kind of a spraying method where you're, and I'm talking about a big field, like acres and acres and acres. Yeah. Okay? It tells you, if you know a certain germination rate for the seeds, it tells you how many seeds you need to go out there with to guarantee that you're 95% likely to actually cover all the seeds so that most of the field, maybe 95% of the field, will germinate. Okay. It gives you an idea of an upfront resource cost. That's in the realm of natural resources. You can also apply it to pretty much anywhere. The quiz for this week is a little whimsical. It's Max and his Legos. But it's the same exact idea. So it gives you kind of an average total that you can expect to see. Now, I'm not saying it's meaningful on a die, other than maybe board games. Yeah. But you can see how this actually would also work itself out into your individual careers, your individual disciplines. Is that fair?
Yeah.
Good. Very good question. I mean, it's always a good question to ask what the point of these mathematical exercises is. The big one right now is just to give you guys data collection skills and then analysis skills. You'll see how they become useful once you start getting into your disciplines when you're working towards your transfer degrees. You actually get into yours. But when you hear the term weighted average, which you will inevitably hear as you get into your career, you're doing it right now. These are the weights. Those are the weights. The data are being multiplied by the weights, and then you divide by how many data points you've got. Boom, and out falls your average. Beautiful. Sorry.
Electrical.
Why couldn't you just add up the small numbers, the ones on the left?
Why can't you just divide by 7?
Yeah.
Why can't you just add up the numbers on the left and divide by 7?
Because there's 2 of each of the, well,
Say that again, Shelby?
it's like, because there's 2 of 52, 3, like you said, 3 of 52, you can't
so
just divide by.
I want you to make sure you guys heard Kelly's awesome question. I'm going to turn the camera too so we can see what you're talking about. Kelly said, why don't we just add up 2 plus 3 plus 4 plus 5 plus 6 plus 7 and then divide by, there's 6 actually.
It ends up as 3.85.
It ends up at 3.85.
Yeah.
Why can't we just do that?
I say 3.86.
And it's up to 4.5.
Why can't we just do that? Why are we even talking about these numbers over here? Why are they even important? Why are they even important? Let me ask you a different question. Why?
It's because that's how often that we...
That's the question I was trying to phrase right there, Trey. You did it for me.
Yeah.
The thing about having the frequencies over here. Okay, so let me ask you this. take your GPA. Rather than considering how many credits certain classes are worth, suppose you're taking a 1-credit HHP class, a 2-credit library class, a 3-credit speech class, and a 4-credit math class. And you get an A in the HHP class, a B in the 2-credit class, an A in the 3-credit class, and a D in the 4-credit class. Well, the D's a 2, the A's are 4 each, and the B is a 3. So what's 4 plus 3 plus 2 plus 2? That's 11, yes? 11 divided by 4 is going to give you a GPA of 2.75-ish, somewhere in there, right? But it's not. It's going to be lower than that. Why? Why? Why?
The weights.
The weights. You have to account for the weights because not every data point is created equal. If you add 2 plus 3 plus 4 plus 5 plus 6 plus 7 and divide by 6, you are saying that 7 happens just as much as 6 and 6 happens just as much as 5, but they don't. These guys happen a lot more than these guys on the ends. That's why you have to account for the weights. This is a GPA. It's a fantastic question. And that's what Shelby said. She said you have to account for how, and Trey, you echoed this. You have to account for how frequently these things occur. It looks like the majority of what happens about right here. Now, it just so happens that right here is pretty close to right there, which is where your average falls, right? Your average falls directly between 2 and 7, which is 4.5. But you can see how as these data points vary more and more, there are going to be more and more discrepancy. So the weights talk about how frequently they occur. Is that fair enough?
Yeah.
It's like taking 6 people's incomes, one of which is a multimillionaire, and 3 of which are middle class, and 2 of which are destitute, and just saying add all their salaries together and divide by 6 and say that's what the average salary of somebody in the United States is. I mean, you can do that. It's just not correct to do that because the multimillionaire is far rarer than the middle class. You see what I'm getting at? So you have to weight it with a frequency of allotment, which is what we're doing right here.
Well, with credits, like you were
Yes,
saying.
that's exactly right. Here's where your credits would go here.
So would that mean that the weight of 4 is
4 times
greater?
as exactly.
So you would just count the 1 once and the 4.
So your D,
4 times.
your D, which I actually used the wrong number.
I get
The
the
D
right
is
number.
actually a 1. C is 2. D is 1. So if you got a D in a 4-credit course, that's actually worth 4 quality points. 1 times 4.
Yeah.
If you got an A in a 1-credit course, that's also worth 4 quality points. 4 times 1. Does that make sense?
Like
So you can
pick
see
one
why
and
an A in
then
Math 105 is way more valuable than an A in, say, weightlifting. Because an A in Math 105 is 4 times 4. 4 credits times 4 for the A is 16 quality points.
Got it. So
That's why it's worth so much.
Yeah.
How many of you guys have manually calculated a GPA before? Manually, actually written it. Okay, I got a quiz for next week. Perfect. Perfect.
Actually, that would be
That's a great quiz for next week, yeah? That's a great quiz. Calculate your GPA. Oh, I got a good one too. And then you can plan on what you have to get next term in order to get a cumulative GPA of, oh, this is
I think we touched on it too.
Oh, you did? This is a big part of 243, but how many of you are going to take 243? Very few of you, yes? Nobody here today. Oh, a couple of you today. Good, good. You're thinking about it. There, I got it.
Well, I think I have to.
Oh, God, yes. And 244. Oh, hell yeah. If you don't take it now, you get it eventually. You might as well take it now. It's cheaper. So, yeah, this is a very, I did touch on 243 at length, ad nauseum. But this is a perfect example of it, and it might be more applicable to you guys in your worlds right now. But first off, let's collect some data let's collect some other data until we see all the faces. Now, I'm not going to have you calculate this manually, this average manually, because there's going to be too many outcomes. But let's collect the data and have Excel do it for us. I'm going to shut this off till we get all the data.